problem on rolling with slipping, and you're trying to find when the ball will roll without slipping. So a bowling ball is thrown, and right now it has V equals 5 meters per second. So let's write this out. The ball is going this way with 5 meters per second. And there's a frictional force this way. Friction force equals mg mu. So we're asked to find when V equals omega r. We know that V of t equals V initial, which is given, which is 5, plus acceleration times time. Acceleration is going to be negative. And we know that ma equals negative force friction, which equals negative mg mu. So therefore, acceleration is negative g mu. And we also want to find what omega is. Omega of t equals omega initial, which is going to be 0, plus alpha t. And we know that alpha is going to be equal to torque over moment of inertia. And torque is going to be radius times the force applied, which is the force of friction. And that is going to be Rmg mu. That's all over the given I, which is 2/5 mr squared. After factoring it out, that becomes 5/2 g mu over r. So given these equations, we want to set when omega r equals v. So our equation for v is 5 minus mg mu will equal r times omega of t, and omega of t equals alpha t. Whoops, okay, so alpha is 5/2 g mu over r. And then t for time. The r here and r here cancel out. So we're left with 5 equals mg mu plus 5 oh my god, whoops. The acceleration here is not mg mu, it's just it's just g mu t. So over here it's just going to be g mu plus 5/2 g mu over r. Whoops, the r is gone as well. T. So 5 will equal to g mu t times 7/2. So t equals 10/7 10/7 over g mu, and it tells us that mu is 0.08 and g is going to be 9.8. Plug it in a calculator. So 10 divided by 7 divided by 9.8 divided by mu, which is 0.08. That gives us our final answer of 1.82 seconds. So again, this problem, all we had to do is find when V equals omega r. We're given that V initially is 5, and we're given a friction force. The friction force will cause omega to increase, and it will also cause V to decrease. So we're just finding when V equals omega r, and after manipulating and using algebra, we come up with T equals 1.82 seconds.